So now, let us continue to the topic of combining Boyle's and Charles' law. So, sa kaning nga topic is ang tanang uh, tanang tanang law sa Boyle's and Charles' law is gi-combine na niya sa katong ideal gas properties. We have this dimensional form in terms of processes of uh, these gases. We have P1 B1 over T1 is equals to P2 V2 over T2. So let us consider this hot air balloon. So why is it that hot air balloon ascend to the air or atmospheric in a atmosphere? So it because that when we heat the hot air balloon, so mo increase ang iyang temperature. So the warmer the air, so the least the density. So which means mugaan ang iyahang gases. So mo rin lift sa imuhang hot air balloon. Okay? So before that, let us solve some problem in terms sa topic sa equation, ideal gas equation state. So, kanisa sample problem number 2. It is planned to lift in moves logs from almost inaccessible forest areas by means of balloons. Helium at atmospheric pressure 101.325 kPa and temperature 21.1 degrees Celsius is to be used in the balloons. What is minimum balloon diameter? Assume spherical shape will be required for a gross lifting force of 20 metric tons. Okay, so this problem we have to para ma-easily to compute or to solve this problem or to demonstrate. So let us illustrate unsay gipasabot sa kaning problem. So maghimo ta og balloon or spherical shape. So assume that this is a spherical, no? So ang kanidang balloon mo ay magpa-help to lift up the lugs. So unsa nang lugs? So mo na part sa usa ka kahoy nga giputol. So gitay kunuhay siya sa usa ka balloon. So mo'y uh, lift sa tuang na, sa tuang lag. So na siya downward or weight sa usa ka sa usa ka lag which is 20 metric tons. So in terms of kilogram, in 1 metric ton we have 1,000 kilogram. So in terms of 20 metric tons in terms of kilogram, so 20 times 1,000 we have 20,000 kilogram. But kung ato ni ikat lang ang iyang gitay para dili sa among tanawon. So para ma-equilibrium ang usa ka system, so if we cut this tie, so naay pa upward nga 20,000, so nasay pa downward nga 20,000. So i-consider lang nato ang balloon. So we have 20,000 kilogram. And then we have the mass of the helium inside the balloon in the mass of the air, which is help to lift up the balloon. So kana. So by create the equation in terms of masses, so we can get this equation by summation of forces. So mass of the lugs or the lifting force, we have this 20,000 plus the sa pa yung downward force or downward mass, we have mass of the helium is equals to mass of the air. So in order to get the value of the volume of the sphere, so we can use the ideal gas equation state. So unsa man to nga equation? We have PV is equals to MRT. So kana. So mass, PV, pressure, volume, V is equals to mass, R is the gas constant in the temperature or the absolute temperature. So now, but we can kanang wapata kay baw sa iyahang gas constant sa usa ka helium. So unsa atong gamiton nga equation? So natay equation nga R is equals to R bar over the mass, di ba? So ang R bar na to, which is the universal gas constant, and the M is equals to the molar mass. So R bar, we have the value of the universal gas constant, which is 8.314 in terms of metric system. So kilojoule per kmol over the kilojoule per kmol of Kelvin. And then the molar mass is equals to pila ang molecular weight or molar mass sa helium. We have 4 kilogram per kilomole. So para makuha na to, so ato i-substitute diri. So 8.314 over the 4 is equals to 8.314 over 4 is equals to 2.0875 kilojoule per kilogram Kelvin. Kana. So, di ba nakuha na naman nato in the previous problem ang gas constant of the air, which is equals to 0.287. So now we can equate by in terms of volume. So unsa atong gamiton kani nga equation, which is PV is equals to MRT. So 20,000 plus the mass of the helium, which is the pressure is 101.325. Wait. 101.325 kPa times the volume in terms of volume, and the gas constant of the helium is 2.0875, and then the absolute temperature, which is 21.1 plus 273. Then nato sa reason para maiga ito ang equation is equals to 101.325 times the volume over 0.287, the gas constant of the air, and then the absolute temperature of the air, which is 21.1 plus 273. So now we can get the volume of the sphere. So 20,000 ato lang sa ni kanon anayon 101.325 over 2.0875 times 21.1 plus 273. Yan. So, ship store A. Ship store A. And then sa air na punta ng equation. 101.325 over 0.287 times 21.1 plus 273. And now we can get the value of the air in terms of volume. So 20,000 plus alpha A times na nato alpha X, alpha equals times alpha B times alpha X, ship store A. Now we can get the volume of the sphere, 19316.2876 meter cube. So by using the formula of the sphere, which is 4/3 over 4/3 pi r cube, so we can get the value of the minimum balloon diameter. So V is equals to 4/3 pi r cube. So we have the value of volume 19316.2876 is equals to 4/3 pi r cube. So now we can get the radius of the balloon. So 19316.2876 alpha equals 4/3 times pi times in terms of alpha x lang sa ta, shift solve, wait, 19316.2876 alpha equals 4/3 times pi times alpha x, shift solve, and then cube root of answer. So we can get the radius of the balloon 16.64. So ang ipangita diri ang minimum balloon diameter. So Di- diameter is twice the radius, no? So 2 times 16.64. So we can now get the value of the diameter, minimum balloon diameter, 33.3 meter. So mo na answer. So now let us proceed to the topic of specific heat. Specific heat. Specific heat is defined as the energy required to raise the temperature of a unit mass of a substance by 1 degree. In general, this energy depends on how the process is executed. In thermodynamics, we are interested into two kinds of specific heat, which is the specific heat at constant volume, CB, and specific heat at constant pressure, or denoted as CP. So the specific heat capacity of a material is a physical property. It also an example of an extensive property. So this specific heat is the kanang it means the ability of the material nga makaresist ba siya nga unsay gihatag sa heat by raising the temperature. And the heat capacity is defined as the ratio of the amount of energy transferred to a material in the change in temperature that is produced. So in terms of dimensional form, so we have uh, so in terms of dimensional form, so we have C denoted as C ang specific heat. Ano, dire is equals to heat energy over the mass times the change of temperature. Yeah. So in mathematical form, we have C is equals to, or differential quantities, we have C is equals to dq over m the delta t. Or we can get the formula in term by using the integration. So dq is equals to mass times differential temperature. So to disregard the differential, so Q nato in terms of 2 to 1. So Q nato is equals to, napa ni C, is equals to MC. So from point 2 to 1, we have temperature 2 minus the temperature 1. Kung in terms of constant pressure, we have Q is equals to MCP T2 minus T1. And in terms of constant volume, we have MCB times temperature 2 minus the temperature 1, or the change in temperature. So now, uh, let us discuss unsay mga types of heat energy. So we have latent heat. Uh, wait. So we have types of heat energy. So types of heat energy, we have latent heat and sensible heat. So this energy released or absorbed in the atmosphere. So latent heat is related to changes in phase between liquid gases and solids. And the sensible heat is related to changes in temperature of a gas or object with no uh, change in phase. Just like kanang just like your kuan, mahikap ta og mga init nga butang. So in terms of sense sa ato ang kuan, uh, sense of touch, so ma-feel nato ang kainiton sa uh, kainiton sa usa ka butang. So in our body mo change ang temperature pod. So or another example, the kuan heat energy that heat heat energy that released to the sun, di ba? So kung makuan ta mainitan ta mo change ang atoang temperature without changes sa phase nato. So sa latent heat pod, sa latent heat is the energy released or absorbed in a body that is kanang kuan without changes in temperature. Just like the amount of ice. So sa sa kanang ice, in order to melt the ice, so we have using or we have that amount of ice to we have to absorb that kanang sensible heat to mo change siya sa iyahang temperature and until such time that kanang kuan kanang at a point nga ma-melt siya, so di pa na siya mahitabo nga ma-melt siya kung atong gamiton is sensible heat. So mogamit ta og latent heat aron mo change ang iyang phase into di ba ang atoang ice is in terms of solid phase. So mogamit ta og kanang latent heat aron latent heat of energy aron mo change to into liquid phase. So types of mo na siya. So we have latent heat and then the sensible heat. So in this topic of specific heat, so it is important to note that the relation between added heat, specific heat mass, and temperature change does not apply during a phase change. So which is mao to ang latent heat na to. So the reason for this because heat is added or removed in a phase change does not alter the temperature. So physically the specific heat at constant volume CB can view as the energy required to raise the temperature of unit mass of substance by 1 degree at volume is maintained constant kung in terms of CB. In sa CP in terms of maintain the pressure. So at this point, we introduce another ideal gas property called the specific heat ratio. So sa specific heat ratio, we have this mathematical form or dimensional form. So uh, specific heat ratio or K or equals to, in terms of dimensional form, so we have K is equals to Cp over the Cb. So muna ratio sa iyang constant pressure over the constant volume. So dapat ang kaning nga ratio is greater than unity or greater than 1. So for monatomic gases, its volume essentially constant at 1.667 kung mga monatomic gases. So unsay meaning nga ng monatomic gases? It has kanang mga elements that has one or it has a single atom, just like an helium, 'di ba? Ang helium is consists ra sa usa ka or consists ra of single atom. So the K of the monatomic gases is 1.67. In the diatomic gases, including air, have a specific heat ratio which is equals to, so mga diatomic kuan pod gases which is 1.4. So including the air, so mo na itong gamiton nga specific heat ratio. So how can we equate this relating between the Cp and the gas constant in this the specific heat ratio. So ma-relate na nato no in terms aning katong tulo. So di ba ang ato ang change of enthalpy is equals to change of U plus the change of workflow. Okay? So sa change of H, we have equals to mCp delta T or differential T. Kanan lang. And the change of U is equals to mCb delta T. And the workflow, di ba, ang formula ng workflow is equals to change of PV. So, pwede na to ma-relate ang PV na to is equals to change of pressure pressure volume is equals to MR differential T or change of T. So, kung ato na i-rewrite ang change of H, so change of H, we have M Cp times change of T and M Cb delta T plus the workflow which is Mr delta T. So cancel out the delta T and cancel out the mass. So we can get the R is equals to Cp minus Cb. Okay? Yan. Rk. So now, we have to get the equation in terms of specific heat ratio and the gas constant. So, in terms of Cp lang sa ta. So, diba, sa Cp na to, ang specific heat ratio na to is Cp over Cv. So, the Cp, or ang Cv na to is equals to Cp over K. So, ato ni equate to this equation, R is equals to Cp minus Cv. So, so Cp minus Cp over K. And then, multiply both side, Rk na siya, Rk, so multiply both side times K. So, Rk is equals to Cp K minus Cp. So, kana. New slide. So, Cp, Rk is equals to Cp minus Cpk minus Cp. So, common factor, the Cp, Rk, so Cp, marirate na to into K minus 1. So, ang Cp din na to is equals to Rk over K minus 1. So, kana. So, maupod sa specific constant volume relating with the R or constant gas constant and specific heat ratio. So, we have R is equals to Cp minus Cb. So, di ba, ang atong specific heat ratio is Cp over Cv. So, Cp is equals to K Cv. So, R is equals to K Cv minus Cv. So, the common factor, we have Cb. So, maririte na to into form K minus 1. So, atong Cb is equals to R over K minus 1. So, kana. So, magamit ni siya pagkuha sa Cp na to in Cb in terms sa given nga R and specific heat ratio. So, now let us example number 3 relating with the specific heat. So, sample problem number 3. For a certain ideal gas, R is equals to 25.8 feet lb or pound feet lb per pounds Rankine. K is equals to 1.09. So, what are the values of Cp and Cb? Sa A. B. What mass of this gas would occupy a volume of 15 cubic feet at 75 psia and 80 degrees Fahrenheit. So, sa C, if 30 BTU are transferred to this gas at constant volume in, what are the resulting temperature and pressure? Okay, so first atong kwaon sa ang CP na to by using the formula of CP is equals to RK over K minus 1. So sa R, we have 25.8 times the K nga 1.09 over 1.09 minus 1. So now we can get the value of 25.8 times 1.09 over 1.09 minus 1. So we have 312.47 feet LB over pound Rankine. So in terms na tog BTU, i-over na tog 778 para mahimog BTU per pound Rankine. So over 778. So we have 0.402 BTU per pound mass Rankine. Degrees Rankine. So in terms of CV, we have R over K minus 1. So sa R, we have 25.8 over 1.09 minus 1. So 25.8 over 1.09 minus 1. We have 286.667. So in terms of BTU, so divide na to og 778. So we have 0.368 BTU per pound Rankine. So ato sang kuha ng gas constant, this certain ideal gas. So we have R CP minus CB. So sa CP we have 0.402 minus 0.368 is equals to 0.402 minus 0.368. We have this 0.034 BTU pounds Rankine. So sabi, what mass of this gas would occupy a volume which is have a volume of 15 cubic feet at 75 psi and 80 degrees Fahrenheit. So unsay magamit nato nga equation? Magamit nato nga equation is the ideal gas equation state. So we have PB is equals to MRT. So pressure, we have this 15 cubic feet or 15 feet raised to 3 times sa volume pa na. So sa pressure, na to, we have 75 psia or pounds per inches. 75 para in terms of feet squared siya, i-times na to 144. So, conversion na, no? So, in terms of inches, so 12 inch, so 12 squared, we have 144 inches, inches squared over per feet squared is equals to mass, mo gipangita, and then the gas constant which is 0.034. In the absolute temperature, we have 80 degrees Fahrenheit. So, i-plus na to 460. So, para mahimo siya in terms of Rankine. So, mass is equals to 75 times 144 times 15 alpha equals times alpha x times 0.034 times temperature 80 plus 460. Shift solve, we have mass nga no, dito mo gamit og 0.034, dapat naka-fit LB ni nga R. So 8 times na to balik og 778. 778 kana. So 75 times 144 times 15 alpha equals times alpha x times 0.034 times 80 plus 460 times 778. We have the mass of 11.34 BTU. No, pounds. Pound mass. So kani. So nasayo pa no. Wa ni. So if 30 BTU are transferred to this gas at constant volume, in what are the resulting temperature and pressure? So unsay magamit nato ato? The final para para makuha nato ang the final temperature. So we are using Q, which is in terms of maintaining the volume, which is constant volume, specific heat constant volume is times the temperature 2 minus the temperature 1. We have 30 BTU in M, which is 11.34, and CB is equals to 0.368. So BTU, pounds per Rankine. And temperature 2 minus temperature 1 is 80 plus 460. So, pila na siya? 80 plus, so in terms of absolute temperature, 80 plus 460. So 540. So temperature 2 is equals to, so 30 alpha equals times alpha 11.34 times 0.368 times alpha x minus 540. So now we can get the final temperature of, so we have 547. 547.19 Rankine. So now, let us proceed to pressure. So sa pressure, Because state niya sa condition is constant volume, we have uh, P1 B1 over T1 is equals to P2 B2 over, so constant volume, so cancel out na siya, equal naman na siya, so T2 over T1 ang atong gamiton, which is kang gay Lusak's law. So T2 over T1 is equals to P2 over P1. Yan. So we have the temperature, absolute temperature, 547.19 over the initial temperature, which is 80 or 540 in terms of Rankine, is equals to pressure 2 over the initial pressure, which is 75 psi A, or absolute. So pressure 2 is equals to 547.19 over 540 times 75. So now we can get, or 76 psia. So that's all. Thank you.